On Friday, the 12th of June 1992, the Isle of Man TT circuit was torn apart by a sound Britain had never heard before. Steve Hislop, riding the ABUS-backed white Charger Norton RCW 588, shattered records to beat Carl Fogarty's factory Yamaha on the senior TT. It was a moment of absolute deafening British racing triumph. A twin-rotor Wankel engine, an engine that uses spinning rotors instead of pumping pistons, had just defeated the might of the Japanese motorcycle industry. But the victory was an illusion. As Hislop crossed the finish line, the company that built the screaming machine was bleeding to death. The Norton factory in Shenstone was crippled by financial chaos. The road-going version of the rotary engine was already proving too hot, too thirsty, and too expensive to survive on the street. But the real story of the Norton Rotary is not only the story of a miraculous TT victory. It is the story of how a small group of British engineers tried to save a dying motorcycle empire with an engine that was brilliant, brutal, and ultimately impossible to keep alive. Every week, we tell the stories of British engines, factories, machines, and industrial names that once taught the country what power sounded like, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, at the BSA Research Center in Umberslade Hall in 1970. The story begins not with nostalgia, but with a specific place, at the BSA Group's Research Center in Umberslade Hall, Warwickshire, in the early 1970s. At this moment, the British motorcycle industry was standing on the edge of a precipice. For decades, the parallel twin, a two-cylinder engine that balanced compact size with enough power for the open road, had defined British motorcycling. Outside cafes and small village garages and on winding country lanes, it was a sound riders trusted instinctively. But by 1970, that trust was fracturing. The Japanese manufacturers had introduced the modern inline-four engine, offering multi-cylinder smoothness, electric starts, and oil-tight reliability that the aging, underfunded British factories simply could not match. The BSA Group, a sprawling industrial empire that also owned the Triumph brand, was desperate for a technological leap to bypass the Japanese threat entirely. The answer they found was not a better piston engine, but an engine with no pistons at all. Engineer David Garside, working at Umberslade Hall, began experimenting with the Wankel rotary engine. A rotary engine, a power plant that uses spinning triangular rotors inside an oval-like epitrochoid chamber instead of conventional pistons pumping up and down, completes its intake, compression, power, and exhaust phases simply by spinning. Because there is no reciprocating mass rapidly changing direction, it is inherently turbine-like smooth. It can produce massive power from a block less than half the size of a conventional four-stroke engine. To the British engineers, this was not just a clever design, it was a lifeline. If Britain could perfect the rotary motorcycle, they would not need to compete with Japanese inline fours. They would render them obsolete. Garside started with a single-rotor engine based on a German Fichtel and Sachs design, originally intended for a stationary application. He extensively re-engineered the cooling system. In a Wankel, the combustion always happens in the exact same part of the housing, creating immense concentrated heat. Garside designed a system where incoming intake air was drawn through the center of the spinning rotor to cool it before entering the combustion chamber. It was an elegant piece of engineering, but it was being developed inside a corporate structure that was already collapsing. By 1973, BSA was financially ruined. The British government forced a merger with Norton Villiers to create Norton Villiers Triumph, or NVT. But NVT was born into chaos. Industrial strikes, factory sit-ins, and chronic underfunding tore the new company apart. By 1977, NVT was liquidated, yet the rotary engine refused to die. The project was salvaged by former Norton Villiers chairman Dennis Poor and moved to a small, unassuming factory in Shenstone, Staffordshire. Here, away from the silent, abandoned volume production lines of the traditional Midlands factories, a skeleton crew of engineers kept developing Garside's vision. They expanded the design into a twin-rotor configuration, displacing 588 cc. By the early 1980s, the new Norton company desperately needed a market. The consumer motorcycle market was utterly dominated by Japan. British riders were no longer willing to risk their wages on experimental domestic engineering when a Honda or Suzuki offered guaranteed reliability and a vast supportive dealer network. But there was one market in Britain that was heavily incentivized to buy British: the police forces. For regional police constabularies, the motorcycle was a working tool. Officers spent 8 to 10 hours a day in the saddle. Traditional large-capacity British twins vibrated so violently at motorway speeds that riders suffered from intense fatigue and numb hands. The police needed a machine that was effortless, fast, and smooth. In 1984, the Shenstone factory launched the Norton Interpol 2. It was a heavy, fully fared police motorcycle powered by the air-cooled 500 HCACC twin-rotor engine. It was not sold to the public. It was a fleet machine deployed exclusively to constabularies, the RAC, and military police units across Britain. When the first Interpol 2s arrived at police transport depots, the initial reception was astonishment. The rotary engine was devastatingly fast and completely devoid of vibration. An officer could open the throttle on a motorway pursuit, and the machine would simply surge forward with a seamless, linear thrust, emitting a strange, vacuum-like hum rather than the traditional mechanical clatter of a piston engine. For a brief moment, it seemed Shenstone had pulled off a miracle. The factory had orders. The British police were riding British motorcycles again. The twin-rotor block was proving that domestic engineering could still produce a machine that felt like the future. But a motorcycle does not only exist in high-speed motorway pursuits, it exists in traffic. It exists idling at junctions, crawling through town centers, and creeping along in slow-moving escorts. And it was here on congested British streets that the fundamental physics of the rotary engine began to turn against Norton. A traditional four-stroke engine, an engine that completes intake, compression, power, and exhaust strokes across 4 piston movements, distributes its combustion heat relatively evenly around the cylinder. A rotary engine does not. The exhaust port of a rotary handles a continuous, violent stream of burning gases. The heat generated by the 500 cc twin rotor was immense. Because the Interpol 2 was air-cooled, it relied entirely on forward momentum to dissipate that heat. When a police officer was forced to idle in summer traffic, the heat trapped inside the enclosed fiberglass fairings had nowhere to go. It soaked into the frame. It roasted the rider's legs. In severe cases, the heat from the exhaust system became so intense that the plastic bodywork of the motorcycle literally began to melt. Furthermore, the apex seals, the crucial metal strips at the 3 tips of the triangular rotor that seal the combustion chambers, were subjected to extreme friction and thermal stress. While Garside's engineering was brilliant, police fleet mechanics soon found that if the oil metering system faltered even slightly, the engine would lose compression rapidly. The service network, the workshops and depot mechanics tasked with keeping the fleets on the road, suddenly found themselves dealing with a power plant that demanded aircraft levels of maintenance precision in an environment built for rugged simplicity. The engine was smooth, and the police orders provided a lifeline. But Shenstone had not yet realized that a police fleet requires more than just effortless speed. It requires a machine that does not melt its own fairings in traffic. The Interpol 2's heat problem was threatening to quietly kill the entire rotary project. If a police fleet could not keep the engine cool in a town center, the consumer market would never accept it. The Shenstone management, operating on a shoestring budget, focused entirely on making the police bikes marginally more reliable. They did not want to push the engine harder. They simply wanted it to survive a shift. But inside the Shenstone factory was a man who understood that the rotary engine was hiding a terrifying amount of untapped potential. His name was Brian Crichton. Crichton was a former motorcycle racer and a brilliant pragmatic mechanic who had joined Norton in 1984 as a service engineer. His job was to maintain the police fleets, traveling to constabularies to fix the very heat and seal issues that were plaguing the Interpol 2. But when Crichton looked at the 588 SEC twin rotor block, he did not see a flawed fleet machine. He saw a racing engine that was being suffocated. He understood a fundamental truth about the Wankel design. Because there were no reciprocating pistons, valves, or camshafts to float or brake at high speeds, the engine's rev limit, the maximum safe rotational speed of the engine, was exceptionally high. If he could solve the cooling problem, he could rev the engine harder. If he could rev it harder, it would pull more fuel and air. And if it could pull more fuel and air, it would produce staggering horsepower. Crichton took his proposal to the Norton management. Let him develop a racing version of the Rotary to prove its durability and speed to the world. The management, terrified of the cost and focused entirely on the police contracts, refused. They told him to stick to fleet maintenance. When Crichton persisted, modifying a scrap engine in his own time, the corporate response was not encouragement, it was exile. He was banished from the main engineering and assembly areas and relocated to the caretaker's shed, a damp, drafty brick outbuilding on the edge of the Shenstone factory grounds. In the history of British engineering, the shed is not just a building, it is an institution. It is where garagiste ambition, the uniquely British tradition of small teams working in basic conditions to beat large corporations, thrives. Surrounded by parts bins, old service manuals, and scrap metal, Crichton set to work off the clock, completely bypassing the boardroom. The primary barrier to making power was still the extreme heat. The air-cooled interpole engine used a mechanical fan to force cooling air through the center of the spinning rotors. But at high speeds, this fan became a restriction, drawing power away from the engine and failing to move enough air to keep the internal temperatures manageable. Crichton needed a way to pull massive amounts of cold air through the engine block without draining horsepower. The solution he engineered was a masterpiece of applied physics, an exhaust ejector system. An exhaust ejector system, a method of using the high-velocity flow of escaping exhaust gases to create a vacuum, thereby pulling fresh, cooling air through the engine, was a concept borrowed from aviation, but it was revolutionary for a motorcycle. Crichton redesigned the exhaust system so that the violently fast, expanding exhaust gases from the rotary combustion chambers rushed past the exit of the cooling channel. According to Bernoulli's principle, this high-speed flow created a zone of extreme low pressure, a powerful vacuum. This vacuum sucked cold, dense air directly through the center of the engine's rotors at a massive velocity. The harder the engine ran, the faster the exhaust gases escaped. The faster the exhaust gases escaped, the harder the vacuum pulled cold air through the block. Crichton had created a self-regulating, incredibly efficient cooling system with zero moving parts. With the heat problem solved, the restrictions were off. Crichton altered the intake ports, adjusted the carburetors, the mechanical devices that mixed petrol and air before it entered the engine, and advanced the ignition timing. When he finally mounted his shed-built engine to a dynamometer, a machine used to measure an engine's horsepower and torque output, the results shattered the factory's assumptions. The standard Interpol 2 engine produced a respectable 85 horsepower. Crichton's modified engine, screaming in the dim light of the caretaker's shed, produced over 130 horsepower. But it was not just the power figure that shocked the few factory workers who wandered over to the shed. It was the physical violence of the machine. A highly tuned rotary engine, stripped of its heavy police silencers, does not sound like a conventional motorcycle. It emits a tearing, ear-splitting, high-pitched shriek that vibrates deep in the chest. When Crichton opened the throttle, the noise was so deafening it rattled the windows of the main Shenstone assembly plant. Long tongues of blue and orange flame spat furiously from the open exhaust pipes on deceleration. It was a brutal, overwhelming display of mechanical aggression. Crichton had taken a quiet, overheating police motor and turned it into a fire-breathing monster in a damp brick outbuilding. When he bolted this 130 horsepower engine into a modified Interpol frame and painted it silver, the prototype, known as the White Charger, was taken to a test track. It was devastatingly fast, easily outpacing the dominant Japanese superbikes of the era. The Norton management, previously hostile to the idea, suddenly realized that the man they had banished to the shed had just handed them a weapon that could put the Norton badge back on the front page of every motorcycle publication in Britain. Crichton had proved that the Rotary could produce terrifying power, but power in a shed meant nothing until it was unleashed on a British race circuit. The transformation from a discarded police fleet project into a national racing obsession began at a small, windswept airfield circuit in Yorkshire. In late 1987, Brian Crichton's prototype, now designated the RC588, was entered into its first national race at Carnaby. Ridden by Malcolm Heath, the Silver Machine did not just compete, it dominated. The British motorcycle racing paddock of the late 1980s was an ecosystem entirely defined by Japanese engineering. The starting grids were filled with Honda V4s, Yamaha inline fours, and Suzuki superbikes. British mechanics and garagist teams, the independent racing outfits that ran on tight budgets, late nights, and massive dedication, had long ago accepted that if you wanted to win, you bought a Japanese block. The idea of a British manufacturer arriving with a completely radical, unproven engine layout and immediately taking the fight to the establishment seemed like a ghost from a bygone era. But the Rotary was real, and it was violently fast. The Carnaby victory forced the Norton boardroom to finally acknowledge what Crichton had built in the caretaker's shed. For the 1988 season, the factory sanctioned a genuine racing effort. But it was in 1989 that the Norton Rotary moved from being a fast experiment to a cultural phenomenon. That year, the team secured sponsorship from the tobacco brand John Player Special. The screaming rotary machines were painted in the legendary JPS black and gold, a color scheme that immediately evoked memories of British motorsport dominance, echoing the Lotus Formula One cars of the 1970s. When the black and gold JPS Norton RCW 588 rolled out of the race transporters at circuits like Donington Park, Brands Hatch, and Mallory Park, it stopped the paddock in its tracks. The twin-rotor racing engine, now producing closer to 145 horsepower, behaved like nothing else on the grid. Because the rotary design lacks conventional pumping pistons and valves, it has virtually no mechanical engine braking. When riders like Steve Spray and Trevor Nation rolled off the throttle entering a fast corner, the engine did not slow the rear wheel as a four-stroke Japanese superbike would. It freewheeled, requiring a completely different, highly aggressive riding style that relied entirely on the brakes and extreme lean angles. But it was the sound and the spectacle that captivated the British public. When the RCW 588 decelerated, unburnt fuel would ignite in the extreme heat of the rotary exhaust system. Long, violent tongues of blue and orange flame would spit from the open exhaust pipes, sometimes reaching 2 feet in length. The noise was apocalyptic. It was a high-frequency mechanical shriek that cut through the deep bass of the four-stroke machines and the raspy wail of the racing two-strokes. Fans began flocking to the fences of British circuits, leaning over the barriers just to feel the physical vibration in their chests as the black and gold machines tore down the straights. It was not merely a motorcycle race anymore. It was a resurrection. In a Britain where an engine could decide whether an aircraft lifted from a grass airfield, a lorry made its delivery, a motorcycle carried a rider through the night, a bus left the depot, a racing car survived the next lap, or a luxury car kept its silence at speed. Power was not an abstraction. It was metal, fuel, labor, heat, sound, repair, risk, and trust. For the thousands of British spectators standing trackside in the damp chill of a Sunday afternoon, the Norton Rotary was a rolling, fire-breathing statement of national pride. It proved that British engineering was not entirely dead. In a damp Midlands shed, a few stubborn men had built an engine capable of tearing the Japanese racing empire apart on British soil, and they did exactly that. Throughout the 1989 season, the JPS Nortons were unstoppable. Steve Spray rode the howling, flame-spitting RCW 588 to victory after victory, ultimately claiming both the British Formula One Championship and the Super Cup Championship in a single, devastating year. The machine that had started as an overheating police motorcycle had just become the undisputed king of British tarmac. The success of the RCW 588 on the track created a wave of national euphoria. But Norton's management knew that racing trophies alone could not keep the Shenstone factory open. To survive, the racing prototype had to become a production reality. The British public needed a machine they could buy, register, and ride on the street. In late 1989, Norton unveiled the answer, the Norton F1. It was not a compromised, diluted commuter bike. It was effectively a street-legal replica of Steve Spray's championship-winning race machine. Draped in the exact same iconic black and gold John Player Special livery, the F1 looked like it had taken a wrong turn out of the Donington Park pit lane and ended up on a British high street. The engineering required to translate a fire-spitting track weapon into a road motorcycle was immense. To make the violent rotary engine survive the unpredictable realities of road use, the engineering team had to abandon the air cooling of the old police bikes. The F1 utilized a liquid-cooled version of the 580cc twin-rotor block. Liquid cooling, a system that pumps a water and coolant mixture through internal engine channels to absorb heat before passing it through a front-mounted radiator, was absolutely essential to manage the extreme thermal loads of a road-going Wankel. The rest of the machine was an uncompromising catalog of premium performance. It featured a twin-spar aluminum frame, a rigid, lightweight chassis structure designed to handle extreme cornering forces. Built by the renowned British specialist frame maker Shenstone, it was fitted with top-tier white power suspension and Italian Brembo brakes. The British motorcycle press erupted. When the first test rides were published in 1990, the F1 dominated magazine covers across the country. Journalists praised its staggering mid-range torque, the twisting force that dictates how hard a motorcycle accelerates out of a corner, and its uncanny vibration-free power delivery. The rotary engine did not punch or clatter. It simply gathered speed with a relentless, turbine-like thrust. Even heavily silenced for the street, the liquid-cooled twin rotor retained a muted version of that terrifying track shriek. It did not sound like a conventional motorcycle on a British motorway. It sounded like a low-flying aircraft. Before the F1, British motorcycle showrooms had become monuments to Japanese scale and efficiency. If a rider wanted everyday reliability, they bought a Honda. If they wanted raw, accessible speed, they bought a Yamaha or a Suzuki. The surviving British engine names had largely been relegated to the status of classic curiosities, machines requiring a drip tray in the garage and a constant supply of spanners. The Norton F1 shattered that perception overnight. It commanded a completely different kind of respect. It drew massive crowds at the National Exhibition Center motorcycle shows, with enthusiasts pressing against the barriers just to study the complex routing of its cooling system and the seamless, hand-finished welding of its Shenstone frame. It was a machine that demanded to be taken seriously, proving that British industry could still manufacture a halo product that the rest of the world envied. The racing momentum only fed this commercial myth. The black and gold rotaries continued to terrorize the British championships. Legendary riders like Robert Dunlop took the rotary to victory at the high-speed Northwest 200 road race in Northern Ireland, proving that the engine could survive the brutal, sustained full-throttle punishment of public road circuits. The Norton badge was no longer a relic of the 1960s. It was the ultimate defiant statement of modern British speed. When a rider looked at an F1 parked outside a Midlands cafe or heard that unmistakable shriek echoing across a race paddock, they were not just looking at a motorcycle. They were looking at a symbol of industrial resurrection. The F1 was the ultimate expression of what the rotary could be when unchained from the practicalities of police fleet duty. It was fast, it was beautiful, and it sounded exactly like the future Britain wanted to build. The black and gold rotaries had given Britain its pride back, but racing glory was an illusion that the balance sheet could no longer afford to sustain. The first crack in the Norton Rotary empire did not appear on a high-speed straight at Donington Park. It appeared in slow-moving traffic on a damp British weekday. When the Norton F1 finally reached the public in 1990, the illusion of the ultimate race replica violently collided with the brutal realities of the consumer market. The immediate barrier was the cost. In 1990, the Norton F1 was priced at nearly $13,000. At that time, a flagship Japanese superbike, a machine with electric reliability, a vast dealer network, and a warranty you could trust, cost roughly half that amount. The F1 was priced like a hand-built exotic, which meant it was entirely dependent on wealthy enthusiasts who wanted to buy a piece of British racing history. But when those enthusiasts actually rode the F1 on public roads, the fundamental engineering compromises of the Wankel design began to destroy the romance. The liquid cooling system that the Shenstone engineers had desperately fitted to the F1 kept the engine block from melting, but it could not change the physics of rotary combustion. A rotary engine dumps a continuous, violently hot stream of exhaust gases out of a single port. On a racetrack, where a motorcycle is constantly moving at over 100 miles per hour, The airflow pulls that heat away from the chassis. But in a typical British town center, idling at a junction, that heat had nowhere to go. The F1's beautiful, aerodynamic fiberglass fairings acted like an oven. The heat soaked through the frame and directly into the rider's legs. In heavy summer traffic, the motorcycle became physically unbearable to ride. Then came the fuel economy. A high-performance rotary engine is phenomenally thirsty. The F1 struggled to achieve 25 miles to the gallon. In an era where petrol prices were heavily scrutinized, riding an F1 meant planning every journey around the location of the next petrol station. Furthermore, a Wankel engine cannot rely on a traditional oil sump to lubricate its internal seals. To keep the delicate apex seals, the vital metal tips of the triangular rotor, from destroying themselves against the chamber walls, the engine uses a total loss oiling system. A total loss oiling system, a mechanical pump that constantly injects small amounts of fresh oil directly into the combustion chamber to burn with the fuel, meant that the F1 had to be regularly topped up with oil, and it constantly emitted a faint haze of blue smoke. On a racetrack, a smoking exhaust is simply part of the theater. On a high street, it felt like an outdated, dirty technology. The world was rapidly moving towards stringent emissions regulations, and the twin-rotor engine, by its very design, burned oil on purpose. The market reaction was swift and devastating. Despite the massive media hype and the glowing magazine covers, only around 140 Norton F1s were ever built. The consumer market, the financial lifeline that was supposed to save the Shenstone factory, effectively rejected the motorcycle. The engine still ran, but the economics around it had already failed. While the road bike project stalled, the racing program, the one arena where the Rotary was undisputed, was suddenly dragged into a vicious political war. The Japanese manufacturers, watching their highly developed inline-four superbikes being repeatedly beaten by a small British team operating out of Staffordshire, began to heavily pressure the racing authorities. The argument centered on a single, highly controversial question. What was the actual displacement of a rotary engine? Displacement, the total volume swept by pistons inside an engine, is easy to measure in a conventional four-stroke. But a rotary has no pistons. The Norton twin rotor was officially classified as a 580cc engine because that was the volume of a single working chamber. However, a rotary engine fires more frequently than a four-stroke piston engine. The rival teams argued that the Norton was not a 580cc machine at all. They claimed its thermodynamic equivalent was closer to an 1100cc or even a 1700cc piston engine. The racing rulebook, the complex web of regulations that dictate what is allowed on a grid to maintain fair competition, was thrown into chaos. The FIM, the international governing body for motorcycle racing, struggled to classify the machine. Eventually, under immense pressure from the dominant Japanese factories, the authorities began introducing restrictive equivalency formulas. They added massive weight penalties to the Norton rotaries. They restricted their air intakes. The message from the racing establishment was clear. The British garagiste era was over. You were no longer allowed to beat the major manufacturers with a loophole in engine geometry. The JPS Norton team suddenly found themselves fighting not just other motorcycles on the track, but an entire regulatory system designed to slow them down. The rotary engine had proven it could dominate, but a racing engine can become a legend and still lose its world if the sanctioning bodies rewrite the rules of engagement. The engine was being legislated out of motorsport, but the fatal blow would not come from a rulebook. It would come from the boardroom. While the JPS team fought a losing battle against the international racing regulators, the true collapse of the Norton Rotary was happening behind closed doors in the Midlands. The racing success had successfully masked a bitter industrial reality. The company was running out of money, and the engine was running out of time. By the early 1990s, the financial structure of the Norton Company was completely unraveling. The business had become a pawn in a series of complex corporate acquisitions and stock market maneuvers. Corporate consolidation, the process where companies are acquired, merged, or stripped of their assets by holding groups, rarely prioritizes experimental engineering. The executives who now controlled the Norton mark were less interested in funding the expensive, highly specialized machining lines required to build twin rotor blocks, and far more interested in leveraging the historic value of the brand name itself. The immediate victim of this financial chaos was the engineering team. Brian Crichton, the man who had single-handedly dragged the rotary engine out of the caretaker's shed and onto the top step of the British Superbike podium, found himself repeatedly fighting the boardroom for basic development budgets. He knew the engine still had untapped potential. He wanted to experiment with fuel injection and better cooling systems. But the factory was paralyzed by debt. Suppliers were not being paid. The foundry deliveries of aluminum castings began to slow down, and the supply of vital internal engine components began to dry up. Frustrated by the total lack of corporate support and the endless internal politics, Crichton left Norton in 1990. His departure ripped the heart out of the rotary project. An experimental engine layout does not survive purely on blueprints. It survives on the stubborn dedication of the people who understand its unique mechanical language. Without Crichton driving the development forward, the Shenstone factory lost its technical momentum. The engine that had terrified the Japanese manufacturers was suddenly frozen in time. As the factory faltered, the service network, the vital ecosystem of dealers, mechanics, and parts catalogs that keeps a motorcycle running after it leaves the showroom, began to collapse. For the few enthusiasts who had spent nearly $13,000 on a Norton F1, owning the machine became an exercise in mechanical anxiety. Because the Wankel engine was so rare, the average local motorcycle garage did not possess the specialist tools or the knowledge to rebuild it. A conventional mechanic, armed with a standard set of spanners and a lifetime of four-stroke experience, could not simply take apart a twin-rotor block to replace a worn apex seal. The clearances were too tight, the geometry too alien. When an F1 needed a major overhaul, the critical service process where an engine is stripped, inspected, and rebuilt to factory tolerances, it usually had to be sent back to specialists. But as Norton's financial crisis deepened, spare parts became incredibly scarce. A rider whose F1 began to lose compression might find that the replacement rotor seals were simply unavailable. A shattered gearbox could leave a machine sitting under a dust sheet in a damp brick shed for months. An engine can be a masterpiece of garagiste engineering, but if the part supply fails, it quickly becomes a very expensive, very beautiful museum piece. The final insurmountable barrier was not financial, it was environmental. As the 1990s progressed, European emission standards, strict legal limits on the amount of harmful pollutants a vehicle is allowed to produce, were becoming significantly tighter. Governments were preparing to heavily penalize internal combustion engines that burned dirty. The Norton Rotary engine, by its very architecture, was an emissions nightmare. The total loss oiling system meant it constantly burned raw lubricating oil along with its petrol. The extreme heat of the exhaust required a rich fuel mixture simply to keep the internal temperatures manageable, resulting in massive unburnt hydrocarbon emissions. To make a high-performance Wankel engine pass the looming emissions regulations, Norton would have needed to invest millions of pounds into advanced catalytic converters and electronic fuel injection systems. The Shenstone boardroom did not have millions of pounds. They barely had enough money to keep the lights on in the assembly halls. The regulatory pressure created an unsolvable engineering trap. The very characteristics that made the rotary engine so intoxicating on a race circuit, the massive fuel flow, the lack of mechanical restriction, the violent exhaust heat, the flames spitting on deceleration, were exactly the characteristics that made it illegal in the modern regulatory world. The machine could still work, but the environment it was built for had moved on. In 1994, the inevitable finally happened. The Shenstone factory, which had once housed the most ambitious motorcycle project in Britain, was shut down. The production of the rotary engine ceased. The remaining assets, tooling, and intellectual property were sold off, scattered among different holding companies and private investors. The Norton name would survive, eventually passing into foreign ownership and enduring decades of chaotic revivals. But the era of the mass-produced British twin-rotor was dead. The glorious, deafening experiment had failed. It had not failed because the engineers were incapable or because the engine lacked power. It failed because a motorcycle must exist within a system of supply chains, environmental laws, service networks, and financial reality. When that system fractures, the metal stops moving. The engine still ran, the orders slowed, the rulebook changed, the parts grew harder to find, the factory line stopped, the sound faded, the badge remained. The Britain it powered was gone. The rotary had not failed to make power. It had simply run out of a world willing to pay the cost of keeping it alive. The Norton name did not die in 1994 when the Shenstone factory shut its doors. Like many historic British industrial marks, the brand became a commodity. It was sold, licensed, revived, dragged through financial scandals, and eventually reborn under entirely new ownership. Today, a modern Norton factory exists in the West Midlands, building high-end conventional piston motorcycles. But the rotary engine, the screaming, fire-spitting anomaly that had once terrified the Japanese racing establishment, was left behind, abandoned to history as a glorious, unrepeatable experiment. Today, the surviving Norton Rotaries do not belong to the British road network. They belong to the preservation community. They are kept alive by a highly specialized network of mechanics, collectors, and former factory engineers who still understand the alien internal clearances and total loss oiling systems of the twin-rotor block. If you walk through the vast halls of the National Motorcycle Museum in Solihull, you will find them sitting quietly under the strip lights. The Interpol 2 police bikes in their heavy white fairings, the sleek black and gold F1 road bikes, and the battle-scarred RCW Fin 88 race machines. Behind the glass, they look like conventional motorcycles, but the people who stand and stare at them know what they really are. They are a captured sound. When one of these surviving rotaries is brought out of a museum or a private shed to run at the Goodwood Festival of Speed or the classic TT on the Isle of Man, the modern paddock stops. Modern racing motorcycles are brutally fast, but they are heavily silenced by modern regulations. When a mechanic primes the carburetors of an RCW 588 and hits the starter, the resulting high-frequency shriek violently cuts through the air. The blue flames still spit from the exhaust. The sheer physical volume of the engine reminds the crowd of a time when British motorsport was a deafening, visceral assault on the senses. But the most remarkable footnote to the Norton Rotary story does not belong in a museum. It belongs to the man who started the fire in the caretaker's shed. Brian Crichton never abandoned the Wankel engine. Decades after the Norton Corporation collapsed around him, he continued to develop the rotary concept in private. Without a boardroom to restrict him, and without the need to meet impossible street-legal emissions targets, Crichton kept refining the airflow, the cooling, and the geometry. Years later, he unveiled the Crichton CR700W, a track-only, bespoke racing motorcycle powered by a heavily evolved twin-rotor engine. It produced a staggering 220 horsepower and weighed less than a modern superbike. Crichton had proved his ultimate point. His fundamental engineering instincts in the 1980s had been absolutely correct. The twin-rotor engine block was always capable of world-beating performance. It was never the metal that had failed. It was the corporate structure, the lack of funding, the regulatory pressure, and the hostile market reality that had crushed it. This is why the Norton Rotary still matters. It must pass the test of not simply being a piece of misty-eyed nostalgia. We do not remember the Rotary just because it was loud or because it wore black and gold paint. It matters because the Norton Rotary is the ultimate physical argument about the limits of the British garagiste tradition. For a century, the British motor industry was driven by the romantic idea that a lone engineer in a damp Midlands shed, armed with a few spanners and a brilliant idea, could build a machine capable of beating the largest corporate empires on Earth. And for one brief explosive moment in the late 1980s, the Norton Rotary proved that the shed could still win. But a shed cannot manufacture 10,000 identical engine blocks. A shed cannot fund the development of electronic fuel injection to pass European emissions laws. A shed cannot build a global dealer network to honor warranty claims when apex seals wear out in summer traffic. The Norton Rotary did not fail because the British forgot how to build a fast engine. It failed because building a fast engine was no longer enough. The very definition of power had changed. Power was no longer just horsepower and heat. It was regulatory compliance, supply chain logistics, and massive corporate scale. The British garagiste could still build the fastest machine on the track, but he could no longer afford the world outside the paddock gates. Somewhere in a British museum, An old twin-rotor block sits silently on a display stand, its aluminum casings completely still, its exhaust ports blackened by the extreme heat of a vanished era, waiting for a spark that the modern world is no longer allowed to provide. See you in the next video.